Lesson 1-6, adding and subtracting like mixed numbers. The word like here simply means the denominators are the same. And that's important because when you are adding or subtracting fractions and mixed numbers, you need to have denominators that are the same. If you don't, then you need to do some extra work up front in order to rewrite one or both of those fractions or mixed numbers so that the denominators do match. But we'll see that in a later lesson. This lesson is just, in a way, getting us prepared for that with simpler calculations. Let's take a look here. Number one, we're going to be adding these first few practice problems. We'll just be adding. When we add, as the text box says here, you can have your dessert first if you like. In other words, the easy part, adding the whole numbers. 2 and 3 gets us 5. And then we'll add the fractional parts. 1/5 plus 2/5 gets us 3/5. When we add fractions with matching denominators, we just keep the denominator the same, let the numerators do the work. Looking at number 2, let's have our dessert first. 4 and 1 would get us 5. Then we'll add the fractional parts. 2/3 plus 2/3 gets us 4/3. But then notice that 5 and 4/3 doesn't look quite right because the British nanny is standing there waving her scolding finger at us and saying, "Improper! 4/3 is improper." And she's right. When we work with fractions to show an answer in simplest form, we can't have an improper fraction. So we've got to do some regrouping. We've got to look at the 4/3 on its own. We've got to be able to convert that on its own into a mixed number. 4/3 can get regrouped or rewritten as 1 1/3. And now combine that with whole number 5 here. Add them together. 5 and 1 gets us 6. And then the fractional part remains 1/3, 6 1/3. Number 3. Let's have our dessert first. The 3 and the 2 get us 5. Fractional parts next. 3/8 plus 1/8 gives 4/8. This answer will work, but for those of you that noticed that 4/8 can be simplified or reduced, we could also show this in simplest form by dividing the numerator and denominator by 4, which is their greatest common factor. And rewrite 5 and 4/8 as 5 1/2. How did I do that? I noticed that 4 and 8 both share a greatest common factor of 4. And what I do to the top, I must do to the bottom. Problem 4. Have our dessert first. Whole number 1 and whole number 2 gets us whole number 3. Fractional parts. 3/4 plus 3/4 gets us 6/4. But then the British nanny is reminding us that 6/4 is improper. So we must convert or regroup to show this answer in simplest form. And I can think of 6/4 on its own as 1 2/4 or 1 1/2. Right? Remember, 2 and 4 both have a greatest common factor of 2. And then combine this 1 2/4 or 1 1/2 with the whole number 3. to get an answer of 4 2/4, 4 1/2. Number 5. Have our dessert first. Whole number 3 plus whole number 1 is whole number 4. 1/6 plus 5/6 is 6/6, which on its own is just a whole, isn't it? So 4 plus another whole can be shown as whole number 5. 2 4/5 plus 3 3/5. Have our dessert first. 2 3 is 5. 4/5 plus 3/5 is 7/5. By now, we know that 7/5 is improper. We'll have to do some regrouping. 7/5 on its own can get rewritten as 1 2/5. Combine this 1 2/5 with whole number 5. We get 6 2/5. Now, let's have a look at subtracting mixed numbers. In this first example, we can see that 7 4/5 minus 3 1/5. This example, we can use the same steps as we've been using. In other words, we can have our dessert first. We can do 7 minus 3 to get us 4. We can do 4/5 minus 1/5 to get us 3/5. But I'm going to caution you, when you're subtracting, you won't always be able to have your dessert first. And we're going to see that in a moment. In fact, we're going to see that right now. Here, let's try to have our dessert first and see what happens. 4 minus 1 gets us whole number 3. But then we look at the fractional parts. 1/3 minus 2/3. Can't do it. 1/3 is smaller than or less than 2/3. So we can't subtract those fractions. So we're stuck. The way that we can get ourselves unstuck is by looking at what we're dealing with over here. 4 1/3. This fraction, 1/3, needs help. We need to do what's called borrowing from the whole. Borrowing from the whole is a lot like imagining yourself at an arcade, where the video game you want to play takes quarters and you've just got a dollar bill in your hands. What do? You got to find the change machine. Slip that dollar bill in there to get 4 quarters so that you can play the game. This fraction needs help from the whole. We can rewrite or rethink about whole number 4 as whole number 3 plus 3/3, can't we? Look at what I've done. I've taken 1 away from whole number 4 and shown that as in terms of thirds. So the whole number is going to go down by 1, and the 1 that I've borrowed from the whole is going to get added back into the fraction that was already there, 3/3 plus 1/3. And that's how we can rewrite 4 1/3 as 3 4/3. Think about that. What have we done? We've borrowed from the whole. Whole number 4 went down by 1. The fraction 1/3 got the whole added into it. In other words, 1/3 plus 3/3 became 4/3. Now we can subtract. Now we can have our dessert first. 3 minus 1 is 2. 4/3 minus 2/3 is 2/3. We get an answer of 2 2/3. Now, if you didn't get that right away, that's okay. Be patient. We're going to see it again. Number 9. Let's look at it first. Can we have our dessert first? Well, the whole numbers would be fine, and the fractional part will be fine. So this one is actually an easier one. 4 minus 2 is simply 2. 5/8 minus 3/8 is 2/8. Notice that 2 and 8, the 2/8 can be simplified or reduced by dividing top and bottom by 2. And we can show this as 2 1/4. Number 10, 2 1/4 minus 1 3/4. Can we have our dessert first? 2 minus 1, that seems okay, but look at the fractions. 1/4 minus 3/4, can't do it. We're going to need to regroup. We're going to need to borrow from the whole. When we borrow from the whole number is going to go down by 1, so the 2 is going to become a 1. The fractional, the value of the fraction is going to go up because I'm adding that whole back into the fraction. But what am I really adding back into the fraction? I'm adding it in terms of fourths, getting change from the dollar machine. Quarters, in this case, from the dollar machine. It actually makes sense. 4/4 plus 1/4 is 5/4. So I have regrouped or rewritten 2 1/4 as 1 5/4 so that now I can finish the job. When I subtract my whole numbers, they cancel each other out. Subtract my fractions, 5/4 minus 3/4 gets me 2/4, which can be reduced or simplified to 1/2 because 2 and 4 both share a greatest common factor of 2. When I do the bottom, or when I do the top, I do the bottom. Now, number 11, 3 5/6 minus 1 1/6. I can have my dessert first here. 3 minus 1 is 2. 5/6 minus 1/6 is 4/6. Notice that 4 and 6 are both even numbers. They share a greatest common factor of 2. So this can be shown as 2 2/3. And finally, 4 1/5 minus 2 3/5. I can see right away that I'm going to need to borrow from the whole because 1/5 is smaller than 3/5. So in this case, to borrow from the whole number will go down by 1. So the 4 becomes a 3. And the fractional part was 1/5, but now I'm going to add that whole in terms of fifths. I'm going to add 5/5 back into the fraction. 5/5 plus 1/5 is 6/5. Subtract 2 3/5 and finish the job. 3 minus 2 is 1. 6/5 minus 3/5 is 3/5. We get our answer.